So now that you have watched the first part of this pulley example, we found the acceleration of this pulley. Now, what we're going to do is find the tension. And in order to find the tension in these questions, you always need the acceleration. So good thing we found it. So if you were just given this question, you would have to do this beforehand. But since we have, and I've shown you how, we're just going to write down that the acceleration of the system is 1.962 meters per second squared. And we can use that now to our advantage. So a simple Atwood machine has one mass that weighs 10 kilograms and another mass that weighs 15 kilograms. Determine the tension of the system. So we're going to find the tension in the ropes. Now, if we draw this out again, we know exactly what's happening with this system. So here is my little mass 10, and again we call that 2, so this is mass 2, which is 10 kilograms. And here, this is mass 1, which was 15 kilograms. Now, what did we know about this? Well, first of all, in the last video, we found out that the force of gravity here is the force of gravity on 1. So the mass of 1 times the gravity. So we actually found the force of gravity, and we found it to be up here. We found the force of gravity on 1, 147.15 newtons. So this is 147.15 newtons. And then this guy doesn't have as big of a force of gravity because it is a smaller mass. So this is the force of gravity on 2, which will be the mass of 2 times gravity. And we already found that out. We found that out up here to be 98.1 newtons. So we actually have a lot to work with here. But now, let's talk about what's happening in the net forces. So the thing about physics is sometimes it's useful to look at the whole system. So above here, we looked at the entire system. Or sometimes it's useful to zoom in just on one thing in your system and just talk about that. So maybe I just want to talk about mass 1. Or maybe I just want to analyze what's happening to mass 2. So let's start with mass 2 here. So if we just focus on mass 2, what is happening? Well, if we just looked at mass 2 and only mass 2 and ignored what was happening over here, we know a few things. From our last question, we figured out that this guy, mass 2, is actually moving upwards. Okay? So his net force is going up because he is moving up. We determined that the acceleration on mass 2 was 1.962 meters per second squared up. I'm going to use the whole value here, not my rounded. So this is the acceleration of the whole system. But if we want to zoom in just on mass 2, this is also the acceleration of just mass 2 going up. So from here, what if we were just focusing on mass 2, ignoring the other mass, what would be the thing causing mass 2 to shoot up? Because currently the only force is pulling down, which is the force of gravity. Remember, the net force is all the forces adding up together. So currently with my diagram, my net force should be my gravitational force, but it's not because my net force is going up. Well, if we're just focusing on mass 2 with the rope, well, then we can say the rope is the thing pulling on mass 2 to cause it to go upwards. And that would be the tension. So the tension is causing my mass 2 to have a net force upwards. So now let's analyze mass 2. So mass 2 is F net equals tension minus the force of gravity 2. Now you might be wondering, why am I putting a minus here? Because my net force is the positive direction, so that means my tension's in a positive direction. So these things are both going up, so they should be positive. Positive, both going up. Okay, so since they're both going up, they're going to be positive together, whereas the force of gravity is going downwards, so it's negative. Now we actually have a lot that we can solve for here. We can determine the tension. So let's solve for the tension by adding the force of gravity 2. So here, the net force plus the force of gravity 2 equals tension. And now we can start solving, and remember, we're just analyzing mass 2. We're kind of ignoring the fact that mass 1 is here for now. So that means this will be the mass of 2 times the acceleration of mass 2 plus the mass of 2 times the gravity, and that's going to equal our tension. So mass of 2 is 10 kilograms times the acceleration, which we know is 1.962 meters per second squared. We found that in the last video. Plus the mass of 2, 10 kilograms, times 9.81 meters per second squared. And this is going to equal the tension. So let's plug all this calculations in. So this shouldn't be too hard. I shouldn't really have to plug this into my calculator because it's just going to move the decimal place over 1. So 10 times 1.962, that gives me 19.62, and that's measured in newtons because that's the net force. 10 times 9.81, that gives me 98.1 newtons, and that is the force of gravity on this. And then we can add these values together. So my tension ends up being 117.72 newtons, and that's my tension. Now, what did I say at the very beginning when we started talking about tension? I said that it's important to understand the tension in a rope on one end equals the tension of the rope on the other. Let's check if that is true. So I'm stating that this tension should be equal to the tension in this rope. So now what do you think we have to do? Well, now I'm going to zoom in on just mass 1 and kind of analyze mass 1 of what's happening there. So let's analyze mass 1. So I'm going to draw mass 1 over here, just so we can totally have it on its own. So this is mass 1, and again, that's 15 kilograms. What do we know about mass 1? Well, we know that it's hanging in the air, so there's a force of gravity. So the force of gravity of 1 equals mass 1 times g. What else do we know? Well, we know, based on our last question, that this thing is accelerating down with an acceleration of 1.962 meters per second squared. And since it's accelerating downwards, therefore that means the net force is going down. So here, my net force is now going down because it is accelerating that way. Now, something to understand is that this mass 1 is not accelerating down as if it had nothing attached to it, as if I just dropped it and let it fall. That is why my net force vector is smaller than my force of gravity vector. Now, what's making this smaller? Well, that is your rope pulling on the mass upwards, and that, therefore, is your tension. So now we can create our equation. So my net force, and again, since my net force is going down, I'm actually going to make the downwards direction positive and the upwards direction negative. So net force is positive, and that equals a positive force of gravity 1, because it's also pointing down, minus my tension. So now, check out how this compares to our other analysis of mass 2. Mass 2 was tension minus force of gravity of 2, whereas here we have force of gravity of 1 minus tension. So let's see what happens when we solve for tension here. So the first thing I'm going to do is I'm going to add tension to both sides to get it to be positive. So F net plus tension equals the force of gravity 1. And now I'm going to subtract the net force. So now I have tension equaling the force of gravity 1 minus the net force. And here we can see something really interesting. This tension added our net force and the force of gravity. Whereas here, this tension is taking my force of gravity and subtracting my net force. So let's see what happens when we plug in our values in our calculations. So tension is going to equal the force of gravity of 1, which is mass of 1 times gravity, minus the mass of 1, because we're just analyzing mass 1, times the acceleration of mass 1. This will be 15 kilograms times 9.81 meters per second squared, minus 15 kilograms times, what was our acceleration total of this? Well, that was here downwards, 1.962 meters per second squared. 1.962 meters per second squared. And now we can throw this into our formula. Or not our formula. We have it in our formula. Now we can throw it into our calculator. So this is 147.15 newtons. So that's the force of gravity. 15 times 1.962. That's 29.43 newtons. And again, that's the total net force acting on our mass 1. And I'm going to take 147.15 and subtract it by 29.43. That gives me 117.72 newtons. And there's the tension in our other side of the rope. Now, this is one of the most satisfying things I find in Physics 20. We have now just proven that the tension in the rope attached to mass 2 is equal to the tension of the rope found in mass 1. They are the exact same value. So there is our pulley system examples. I hope that made sense to you. I would try out a few questions on your own, and make sure you watch the other videos of some folks showing some different ways we can solve these problems using a bit different mathematics and analyzing it a little differently. And you can kind of choose which way you'd rather use. Other than that, have a good day.